My name is Dr. CHINNAPANDIAN, Dean and R&D Professor, Department of Mechanical Engineering, Saint Peter College and Technology, Avadi, Chennai, Tamil Nadu, India. I'll be your coordinator for this FDP program. Before going to overview of seminar theme and importance, I would like to quote here from Tirukural, written by our Tiruvalluvar 2000 years back. செய்யத்தக்க அல்ல செய்யக்கெடும் செய்யத்தக்க செய்யாமை யானும் கெடும். செய்யத்தக்க செயல்களை செய்யாமல் விடுவதனாலும் ஒருவன் செய்யத்தக்காத செயல்களை செய்வதனால் கெடுவான். செய்யத்தக்க செயல்களை செய்யாமல் விடுவதனாலும் கெடுவான். He will be perish who does not what is not fit to do, and he also will perish who does not do what it is fit to do. The theme of our FDP is timely and crucial in today's world, where energy consumption is increasing rapidly and climate change is a pressing concern. Energy conservation storage technology play a vital role in reducing our reliance on fossil fuels, mitigating climate change and ensuring a sustainable future. Objective of this FDP are to bring together experts from various fields to share their knowledge and experience on energy conservation storage technologies. We aim to provide a platform for discussion, networking and collaboration. At the end of the seminar, we expect to have a better understanding of the latest developments and innovation in energy conservation and storage technologies, as well as potential application and future direction. Our program features is a distinguished lineup of speakers, each expert in their respective field. We have curated a mix of lectures, discussion, and interactive session to keep you engaged and informed. Totally 13 sessions are to be handled for all 6 days by subject experts in the same domain. Truly, I welcome all speakers and thankful who all accept my invitation without any hesitation. When we talk about learning process, our Tamil poet Avvaiyar said that what we know is only a handful, what we don't know is an ocean. So until that, the learning process will continue. In Tamil, kattathu kaiyalavu kalladadu kadalalavu. To our 210 registered participants from various institutions and backgrounds, I extend a warm welcome. Your participation and enthusiasm are what make this program a success. I am confident that over the next 6 days, we will engage in meaningful discussion, share knowledge, and learn from each other's experience. Looking forward to productive and informative session. Thank you for joining. Let us make this FTP a success. Before begin this FTP, I would like to acknowledge the efforts of our management, Saint Peter's College Engineering Technology, Avadi, Chennai, Tamil Nadu, India, by providing advance amount 75,000 towards expenses of this FTP. Then I would like to thank our beloved Principal Dr. S. Purnachandra, Head of the Department, Dr. Satrak Jayasagaran, Co-Coordinator Dr. K. Purusothaman, Professor and COE, and dedicated faculty members who have worked to bring this program together. I am very much delighted to welcome Honorable former Vice Chancellor of Anna University, Chennai, and most respectable my Gurunather and mentor to our faculty development program on energy conservation storage technology for global sustainable development. First and foremost, I would like to express my heartfelt gratitude to our esteemed chief guest and keynote speaker, my Gurunather mentor, Dr. R. Velraj, former Vice Chancellor, Anna University, who accept to inaugurate this FDP and also handling first session today. Sir is one of the expertise identified in the field of thermal energy storage in worldwide. We are fortunate to have such a great personality and we are honored to have you with us today, sir. Energy is important to everyone and his contribution to thermal energy storage and research development is very most important. We would proud to say that we are Indian. Definitely one day our India will become topmost country among the world. I am privileged to welcome our beloved Principal Dr. Purnachandra, who always encourage and support us in all aspects for conducting this FDP. It is my duty to welcome Dr. K. Purusothaman, coordinator of this FDP, and Dr. Satrak Jayasagaran, Head of the Department, my dear colleagues and participants from across India. I am very much happy to introduce our chief guest of today's AICT Atal online FDP on energy conservation storage technology for global sustainable development. At present, Dr. R. Velraj is working as a professor, Institute for Energy Studies, Mechanical Engineering Department, Anna University, and is specified in heat transfer, computational fluid dynamics, and energy storage. He was in the administrative position as Deputy Director, Center for Affiliation of Institution for 6 years from 2004 to 2010. Director, Anna University, FRG Institute for CAD-CAM for 3 years from 2010 to 2013. and Director, Institute for Energy Studies for 5 years from 2013 to 2018. Vice Chancellor, as a Vice Chancellor, and Analyst for 3 years from August 2021 to August 2024. During his tenure as VC, QS ranking of the university increased from 801 to 801,000 band in 2022 to 383 in 2025, which is 10th among the Indian institution. Anand also received the status of first rank among the state universities in the country as per NIRF ranking. He received several awards. Few are DAD Award for his doctoral research in Germany during 1995 to 1997, Tamil Nadu Scientist Award 2014 by the Government of Tamil Nadu, Achiever Award by Appadurai Chair TNEP in the year 2017 for his technology contribution to Tangeto. Active Consultants Award in 2011 by Anna University. Best Innovation Award in 2013 by Anna University. Research Excellence Award in 2019 by CTDT Anna University. Distinguished Researcher Award in 2020 by Anna University. His research credentials: 15 sponsored research projects as a principal investigator, 269 research articles in Journal of High Repute, citation 16,000, H index 67. 5 years in Anna University. 35 PhD supervised. In this, nearly half of the students are attending today. 35 half of nearly more than 15 students are attending this program. Mentored 15 more scholars, patents granted 9, executed 27 consultants projects as principal consultants, 11 projects as co-consultants. Top 2% scientists in the world in the field of energy recognized by Stanford University. Served as expert member, a governing council member for various international research forums, government bodies like Raj Bhavan, TEDA, IEA, Science City, TITCO, TIDAL for IRT, NLC, NIOT, SAMIR, IACT, US Concert, reputed universities and institutions also for the government funding bodies like M1RIE, DST, NIWE and TNCST. Once again, a hearty welcome each and every one of you to this faculty development program on energy conservation storage technologies for global sustainable development. I wish FDP to great successful one. Thank you. Thank you. So with this, I will conclude my introduction part. I call our Honorable Vice Chancellor to inaugurate this seminar. Inaugurate this faculty development program. Sir, over to you, sir.
Dr. CHINNAPANDIAN, am I audible?
Yes, sir. Audible, sir.
Audible, sir.
Thank you for your introduction. I am very happy to inaugurate this FDP program on energy conservation and storage technologies for global sustainable development, organized by St. Peter's College and coordinated by Dr. CHINNAPANDIAN and his team. Good topic, energy conservation and storage technologies. It is need of the hour, and sustainability is the word being used by all disciplinary people these days. The sustainability is a buzzword being used by all scientists, engineers, even politicians, common people. Everybody is using this sustainability. So being an engineers, we should understand this meaning of sustainability very much, and how to bring sustainable world in the near future, so that engineers, whatever damage we have been doing and we have been doing for the last 2 centuries through our technological development, lot of disorder we have made. Now only people understood this disaster we can correct through sustainable measures. So what is sustainable measures? Mostly this word sustainability we can learn from energy and environment very much. Because for our life comfort we need energy, but we use energy for our life comfort. It is possible at the cost of making so much disorder to the environment. We have started using this energy aggressively for the last 200 years, I can say 200 to 250 years. The last 2 decades only we understood, we have disordered this environment very much, and now scientists are looking for sustainable energy for our future energy requirement. When we talk about sustainable energy requirement to safeguard this planet, mostly solar energy is coming to our mind, because that is the primary source of energy for all this energy available in this world. Even fossil fuels which were accumulated in this earth is initially it is from the solar energy. So all this high intense fuel accumulated in this world in the earth over millions of years we have been using in the recent years, in the last 2 centuries. But now only we have understood this is creating greater disorder. So we now started using this renewable energy for all our requirements. When we started telling about renewable energy, it is highly intermittent in nature. This renewable energy, though why we have not used renewable energy all these days, because it is not available continuously. When we want some energy, it has to be available continuously. These fossil fuels, we can keep on excavate from these mines and we can burn this fuel and we can generate electricity continuously, and also we can use this fuel for transport sector and all sectors very easily. But this renewable energy, always it is intermittent in nature. If it is solar energy, it is available only for some 10 to 15 hours based on where we are located. If it is wind energy, it is available for some few months in a year, then remaining months it may not be available. Like this, if it is bioenergy, biomass also, where during this rainy season it may not be available. Tree cutting is difficult. So every renewable energy has some problem because continuous availability is not there. So this energy storage is very, very essential. Energy storage, with the energy storage only you can make this renewable energy continuous. So these organizations have selected thermal energy storage, which is part of one important storage concept for mechanical engineers. And even other electrical energy storage is also very, very important. Thermal storage also playing a major role. Along with this, one more topic is chosen, energy conservation. Because if we don't use energy in a conservative form, the carbon footprint we are making in the environment will be very, very high. So if the devices which we are using are not energy efficient, we are consuming more energy, so that energy has to be generated. So while generating energy, we are dissipating large quantity of carbon dioxide in the atmosphere. So if you are able to reduce the energy consumption for a given requirement, it is much more than using renewable energy. So you should use energy in a conservative form, energy efficient form. So energy conservation is, there are two things involved in that. Energy conservation, if you use energy efficient devices, the energy requirement to complete the task will be minimal. And energy wastage should be avoided. So these two things are also important in the energy sector. Energy wastage should be avoided, and when we use energy for a particular application, with what minimal energy we can complete the task, we should know, so that the the required task will be completed with the minimal energy. That is energy conservation part. So energy conservation and use of renewable energy requires energy storage. So these two are the need of the hour. The organizers have taken these two as the topic for this faculty development program, so that global sustainable development is possible. The sustainability, now you understood, energy conservation is so much important, and using renewable energy requires energy storage. Now the solar energy and wind energy became very cheap. The energy generation through solar and wind became cheaper, but still we are not able to use it continuously for all application because the energy storage is still expensive. So all the countries in the world, all the developed nations and developing nations are now investing a lot of money in R&D, research and development, to make this energy storage technologies also cheaper like renewable energy technologies. So with the full power of R&D, if this energy storage technology is becoming cheaper, then the sustainable energy usage will come in the world, and after that carbon footprint will be reduced appreciably. So it is very essential. All the engineers should focus on energy storage technologies, and whatever energy we are using, that should be in a conservative form. That means the energy spending for the given application should be as minimal as possible, and energy wastage should be avoided. I think this organizers understood about this need for the future energy usage, and based on that they have selected these two aspects, energy conservation and storage technologies, as the thrust area for this faculty development program to bring global sustainable development. So in this, I also want to tell this energy and environment are opposite in nature. Energy and environment are opposite in nature. So when we want energy, it is possible at the cost of making disaster in the environment. So we need to protect this environment. So we should use this energy in a conservative form. Also, we should use renewable energy, which is a sustainable energy for all our energy requirement. Then only we can safeguard this environment. So the sustainability we have understood from the energy and environment aspect, but the sustainability has a lot of meaning. So every human action, there will be whenever we do any activity or any event happening in this world is associated with some disorder. If it is disorder, means there is no sustainability. The sustainability index, if you see, the sustainability index will be very low if there is a high disorder. So here, everyone should understand, if any event happening in this world, if it is very fast, if it is fast in nature, the disorder level will be very, very high. Whatever action, if now the world is going very fast, that is why the disorder level is also very fast. That means the sustainability index is very low. It is high chaotic in nature, and so high disorder is happening. So what you need to understand, any action, if it is very fast, the disorder level is very high, the sustainability index is very, very low. So when we use our fossil fuel for our energy requirement, so fossil fuel, how we can use, we have to burn the fuel. When we burn the fuel, energy is released at a faster rate. It will release at a very high intense rate. That energy, we cannot capture all the energy available in the fuel for our energy, for our requirement. Our technology growth is, though lot of technological growth is there, we cannot convert all the energy which is coming from the fuel into useful energy. Only some 30 to 40% of the energy can be converted into our electricity. Suppose it is energy generation. Electricity generation means we can convert only 40% of the energy. If it is in the transport sector, we can convert only 40% into mechanical energy to drive the vehicle. The remaining energy is dissipated. While the remaining 60% is being dissipated, we are using high intense fuel which is releasing energy at a faster rate. So we cannot convert all the energy into useful form. So what you need to understand, any action which is very fast, there is a disorder, sustainability index is low. So the fuel which we burn the burning rate is very high. So we cannot convert all the energy into useful form. Nowadays, now we are going into automation, artificial. I request all the participants to mute. I think there are some. Please mute your. Yes.
Yes, sir. Only one has to mute. Civil HOD. All other mics are mute condition only. Please mute.
Please mute. Please.
He is the coordinator.
Yes, I will do something.
Okay, the organizers also can do that. Okay, so what I want to convey, any action which is very fast, the disorder level is very high. So solar energy when we use, it is a sustainable source. The conversion is, though the efficiency is not as high as the fossil fuel conversion, energy conversion. Yes, civil HOD.
Civil HOD and Surulvel, please mute your mic, sir.
Okay.
Mr. Surulvel, sir, please mute your mic, sir.
Okay, now I think. Okay, now.
Surulvel sir only he's talking. Surulvel sir, please mute your mic, sir.
No, always the organization should have the control over all the participants. Otherwise, it is sometimes they will without.
Admin sir, CHINNAPANDIAN sir, you can also mute, sir.
Yes, sir.
No. No. Administrator should have
No,
control
but-
over all the participants. You have the
Yes, sir,
right
yes,
to.
sir. Yes, sir.
Yeah. Now, what I want to tell, this action should be as slow as possible. But engineers, we need to make any action very fast. But when we make this energy conversion, if it is from the sustainable source, solar energy, even this full energy, if it is not utilized, there is no problem. There is no problem because that energy is not dissipated away. It is the energy which is coming. If it is going out, there is no problem. So whatever the source, if it is sustainable source, there is no problem for the environment. So for all our energy requirement, we need to use only the sustainable sources like solar, wind or other sustainable biomass energy, so that we can expect this sustainable development globally for all engineering applications. So energy for which, in order to use these renewable sources successfully, we need energy storage. Out of that, various kinds of energy storage.
Hello, sir.
Thermal storage is one area about which I will take next separately one session. I will take about this thermal storage. Okay. So with this, I will stop my introductory session. So now one more keynote session about this thermal energy storage for solar energy utilization. I will start. Okay. Another after a gap of 5 minutes, I request the participants to mute your this session. Otherwise, there will be a disturbance to others. So I request all the organizers also, you can have the control over the participants so that you yourself can do that. So I will start the next session with the slide for this thermal energy storage for solar energy utilization. Now the second slide is pinned now.
Yes, sir. Sure.
Yes, sir. Yes.
Okay. Let me start. There are so many types of energy storage I have told. For renewable energy, for efficient renewable energy utilization, energy storage is very essential. So among the various energy storage, thermal energy storage is playing a major role in thermal applications. There are so many thermal applications also where solar energy is extensively used. So their thermal energy storage plays a major role. And solar energy, in the solar energy utilization, there are two types. Everybody must be knowing about that: solar thermal and solar photovoltaic. In the solar photovoltaic power generation, the solar energy is directly converted into electrical energy. But there are so many applications where we are using thermal energy for our requirement. Even air conditioning also, cool energy is used. It is in thermal form. For cooking, we use solar energy which is in thermal form. There are drying application, we use solar energy, thermal energy. So for these applications, we can utilize solar energy. Again, to use this solar energy continuously, you need energy storage, thermal storage. Why thermal storage is also very important? You should know the electrical energy is being used in building sector. Among the various utilization of electrical energy, building sector alone consumes 40% of the electrical energy. In any country, the building sector alone consume how much? 40%. Out of 40%, 60% of the energy is used for cooling the application. Suppose if it is a hot country, we need cool energy for air conditioning. If it is a cold country, then that countries need hot energy for space heating application. So 60% of 40% is 24% of energy. So 24% of electrical energy utilized in this country, hot country like India, it is used for thermal applications like cooling, space cooling only. So in those applications, we don't require electrochemical battery. Even we can use thermal storage itself. So thermal storage, how it is becoming important, wherever electrical energy is being used for thermal application, we need not use electrical energy storage. It's enough. We generate the application energy, whether it is a cold energy or hot energy, we generate that and then that energy can be stored, which is very cheaper, economical. Okay, and I hope you understood the importance of thermal energy storage. So among the various storages, so thermal storage is also so important. Then I will tell you what kind of energy storage. Before that, what are the various kinds of solar thermal technologies? So you might be knowing about this solar thermal technology, being a mechanical person. I do not know. There are some participants from other discipline. So let me explain some kind of solar thermal technologies also. If the requirement is, for our requirement, application is less than 100 degrees centigrade, the normal flat plate collector or solar chimney in the case of air heating and solar pond may be used. If it is even other kind of collectors like ETC, evacuated tube collectors, can be used. For medium temperature applications, for cooking and all, parabolic trough collector, dish collector also can be used. Fresnel collectors can be used. For high temperature applications, for power plant application, in case if solar thermal energy is used for power generation, then this kind of central tower parabolic dish can be used to generate high temperature source for power generation from solar energy. So you know how this flat plate collector, which is used for low temperature applications, so out of the 100% energy which is falling on the flat plate collector, how this heat balance is, which is shown here in this diagram. So only 60% of the energy will be absorbed. Very good solar collector will absorb 60% of the energy. The remaining energy is going through convection, reflection, radiation, and even through the bottom heat conduction, some 3% is going. And these are all the energy balance for the simple flat plate collector. And this is the evacuated tube collector, where in the same area we can get a little higher temperature than the flat plate collector we can get. This technology is also widely used for solar hot water heater and other applications. And this is parabolic trough collector. So the trough means you can understand this. So in the previous, it is the solar energy is falling on the surface. Here, the solar energy is focused on a line. The bottom one is a mirror only. The mirror, whatever energy which is receiving on the mirror will be reflected through the central tube, where line focus is there. So you will get the energy over through the line. So that means it is little concentrated. All the surface energy is focused on this line. So it is concentrated. The temperature will be around some 250, 300 degrees centigrade you can get. This is Fresnel collector. So this is also like a parabolic trough collector, but these mirrors are located at various places, and it is focused on it is some different mirrors at various places can be focused on this main absorber tube. Again, it is a line focus. The dish focus, this is a parabolic dish wherein you can concentrate this all this energy on the dish to a focus central point. So here the concentration will be little higher. So the higher temperature you can achieve. So like this, in the heliostatic field collector, the energy will be focused on a point on the top of the tower, so that the temperature you can achieve even 450, 500 degrees centigrade. So like a normal fossil fuel based power plant, you can achieve very high temperature steam out of this concept of solar tower, heliostat field collector, and solar thermal energy. So these are the various types of. So how the thermal power plant operates is shown here. Yeah, this collector can be what is that? Parabolic trough or a heliostat tower, or even Fresnel collector also can be used. So the high temperature source which is generated is used to generate steam. That steam is coming to the turbine. The turbine is coupled with the generator, from the electricity generated. So other than the solar collector, all the other devices are similar to the normal thermal power plant. So this concentrating collector, if it is integrated with these other devices which are in the thermal power plant, you can generate electricity also from solar. But this technology, you also should know, this technology became obsolete in the last 10 years because some 10 years or 12 years ago, the solar thermal technology through using concentrating collector, the investment required for 1 megawatt was 12 crores. Investment required through concentrating solar collector and power generation. It was only 12 crores around 2010 to 12. Those days, the electricity from solar photovoltaic power generation was 18 crores. So many countries started investing money on solar thermal based power generation. But what happened? The material peoples and other researchers working on this photovoltaic area, they made the efficiency of the solar photovoltaic cells very high, and also through mass production, the cost of electricity generation through photovoltaic became very, very cheap. So 2010 it was 18 crore, then within a span of 7 years, 2010 to 2016-17 area time, the 18 crore investment required came to 4 crores. So after that, the solar thermal based power generation became obsolete. So some countries, they started investing a lot of thermal based power generation during the period 2010-12 period. They all stopped the project. In the middle also, many people they stopped. Many people they incurred a loss, heavy loss, because they have invested. After that, this became very not economically viable. Many countries in Spain, lot of investment started through some 100 megawatt solar thermal power plant, but they all stopped in the middle during the year 2014-15 period. Because the solar photovoltaic is very cheap. Okay, then you may ask, what is the need for this solar thermal power generation? So that is why this topic is not solar thermal power generation. Now you have to be very careful. The focus of this FTP is energy storage only, energy storage technologies and energy conservation. That is very, very important. Solar thermal technologies for power generation now became obsolete, but still there are lots of application for low temperature and medium temperature solar collectors for process industry application and some kind of cooking application, solar air heating application, solar water heating application. Still it is highly economical. And if you use this for preheating in many industrial applications, it is highly economical, very, very highly economical. Solar flat plate collector, evacuated tube collector, parabolic collector, heliostat collector. Heliostat collector normally now will be not being used because it is for very high temperature applications. That applications is normally for power generation. That became obsolete as of now. So now I hope you understood where solar thermal technologies are highly useful. Low temperature and medium temperature, as of now, it is highly economical. Then I will tell you, for even cooling application, the solar became very cheap. Through solar photovoltaic only, you should generate power. Listen carefully. Solar photovoltaic, make a note of it. Solar thermal, most of you are maybe mechanical engineers, electrical engineers also can understand this very carefully. Solar thermal, the energy conversion, the efficiency of solar thermal conversion is 60%. Some concentrating collector, even it is not 60%, it is around 50%, 45%. Okay. So let us take for power generation, it is 50%. If 50% energy is generated, you know Already in the introduction section, I told you, any heat to electricity conversion, if you make, the efficiency will be around 33%. So 33% of 50% is what? So nearly some 16% only efficiency you will get. From solar to final electricity, solar thermal conversion some 50%. Then that the power generation from steam to electricity is 33%. So that means around 16.5% only you will get net from solar heat to electricity. Okay. But what happened in the electricity, now even 18-20% direct conversion is possible. So the investment required is only 4 crores in solar photovoltaic. Here it is 12 crores solar thermal. Here you get 16% power. In photovoltaic you get 18-20% energy. There the investment cost is only 4 crores. The final output is saying electricity. So obviously nobody will go for solar thermal route for power generation. Again, but still thermal storage, how it is very important, I will tell you. Now you are generating electricity from solar photovoltaic. Out of this energy which you generated, 20% is converted into electricity. Okay. Mostly in the vapor compression refrigeration system or air conditioning system, the COP will be around 3 to 4, 3.5. So if the COP is very high, then again you will get higher. COP means what? For cooling energy generation, the power conversion through electricity will be very, very high. Vapor absorption system and all will not work hereafter. Vapor absorption system, you will use heat energy for vapor absorption system. But there, the COP will be less. But here the electricity directly, if it is used in the vapor compression system, cool energy you can generate. So whenever sunlight is, solar energy is available, you can generate electricity, and that electricity can be used for cool energy generation during the solar sunshine hours. If you are able to use that cool energy generated in thermal energy form, then any time you can use that solar, that cool energy generated from solar energy for your air conditioning application. So that route became very, very cheap. That route, that is power generation through photovoltaic, then that photovoltaic energy generated should be used to operate the compressor in the chiller system. So that energy, that should generate cool energy. That cool energy can be stored in thermal form. So it is a thermal energy storage. So that is very, very economical. Now it is going to become very popular in the coming days because the renewable energy share in the country, any country to enhance renewable energy share. If you want to increase, as of now, this electricity, battery storage is very, very expensive, but thermal storage is economical, cheaper, large quantity of energy also you can store in very easily. So this thermal storage is very, very important in the air conditioning application, and otherwise also hot energy storage also very useful in many industrial process heating application and solar water heating application, drying applications and all. So now I will tell you how to store energy. Now you understood solar energy, where and all it is economical, you understood. Now solar energy, if you want to use it for any application, it should be available continuously. But it is intermittent in nature. That intermittency, if you want to remove, you need what? Storage. So about the thermal storage, for solar energy, for efficient solar energy utilization, I will tell you how it is possible. So utility, there are so many possible applications. Electricity generation standalone, the grid energy can be used, or some hybrid project, industrial process heating applications, from boiling, melting, sterilizing, cooling system, water desalination. These are all industry applications. And in the domestic application, hot water collectors, solar heating, ventilation and air conditioning system, steam cooking, solar cookers, solar food dryers, all these applications you can use thermal storage, whereby the solar energy share you can enhance. Solar energy utilization enhance. So thermal energy storage system for solar energy, like efficient solar energy utilization. So need for energy storage in solar systems, you have understood already. So this is another slide to tell where and all the use of energy storage provide several advantages, allowing renewable power generation to be stored to alleviate. Yeah, now it's, are you able to see?
Yes, sir. Yes, sir.
Yes, yes.
Yeah, yes, sir.
So this energy storage has several applications like renewable power generation to be stored to alleviate the intermittency. Intermittency can be avoided and the peak load management is possible, improving power quality, meeting remote load. So solar energy, where in most of the islands also you can store, you can generate and store, so that most of the islands they use diesel generator for all their requirement, most of the small islands. So where you can install solar power with the storage, continuous utilization is possible. So storage for management of distributed power generation. So there, how to store energy, thermal energy. Now I am going to tell only about thermal energy storage. I request all the participants also to understand about the other kinds of storage like electrochemical storage, various types, now lithium ion battery, metal ion battery, and many other applications from the electrochemical form, and this compressed air energy storage and pumped hydro storage. There are so many kind of storage. Every storage has different advantage. Now I am going to tell about only thermal energy storage, how you can make it. Sensible heat. There are different types of thermal energy storage. Sensible heat storage means it is nothing but raising the temperature of substance, storage material substance. If you increase the temperature and store the energy, if you store the energy, water has very high specific heat capacity. Specific heat among the various sensible heat storage material, water is the best storage material because the specific heat capacity is very high, 4.18 kilojoules per kg Kelvin. That means to increase 1 degree centigrade of water for 1 kg of substance, 1 kg of water, you can store, thereby you can store 4.18 kilojoules. So if you increase the temperature by 10 degrees centigrade, you are storing 48 kilojoules of energy in 1 kg of water. So water is the best storage material among the sensible heat storage material. Like that, some of the very high, but water we cannot use as a sensible heat storage material beyond some 100 degrees centigrade because it will become vapor. So if you want to use sensible heat storage, beyond 100 means you should use some thermic fluids or oil. Thermic fluid is some kind of material, chemical industries they need. So they use heat transfer fluid, some thermic fluids as a heat transfer fluid. So that will not evaporate even at 150 degrees centigrade, 200 degrees centigrade. So at that temperature, if you want to use, so those kinds of thermic fluids can be used. And some kind of rock material, and storing energy in the underground in Canada and the Scandinavian countries like Norway, Sweden, Finland, their energy usage for summer is winter is very high because it is very cold. But summer time, nearly 20 hours they get solar energy. So what they do, the solar energy, they harvest the solar and the heat energy and they dump this energy under the ground in various forms. They will put a borehole and under the ground they will make some pebble beds and that energy will be stored and the pebble beds will be heated. Some rock will be heated. So most of the Scandinavian and Canada countries like very cold countries, they use the sensible heat storage for their space heating application during the entire winter. All the energy all the energy they get during the summer is pumped into the underground, and they take this hot energy during the winter for their space heating application. Okay. So sensible heat storage, very good application is underground storage for space heating by these Scandinavian and Canada countries like Canada. The amount of stored energy depends on specific heat of the medium, temperature change, and the amount of storage material. So if you want to store large quantity of heat, you need large material, substance, and the temperature change. So what temperature change you can make use of that? Some 10 degree, 15 degree only you can use, because below that temperature will not be useful for your application. So you can make use of this temperature, the sensible heat storage material, mostly over a temperature range of some 10 to 15 degrees centigrade only. So latent heat storage means, what is latent heat storage? Latent heat storage is based on the heat absorption and to change the phase of the substance. So I can say ice water itself is a phase change material when you use it to convert from liquid form to solid. So if you want to store energy at 0 degrees centigrade, that means most of the air conditioning application, food preservation application, you can use water as a latent heat storage material and convert into ice. And so that means large quantity of cool energy can be stored in ice form. So you have to generate ice using some chiller plant also you can use. And the chiller plant, which is operated from solar energy, during the daytime you can generate ice and store it. Whenever you need, you can retrieve that cool energy. So this advantage over the sensible heat storage is high heat storage capacity and isothermal behavior, because ice, till it completely melts, that energy will be available at 0 degrees centigrade. So isothermal behavior during charging and discharging. So the application, whatever be the application, if the energy, you can give the energy continuously at the same temperature. Whereas in the sensible heat storage substance, there will be a variation in the heat transfer rate, because the temperature will keep on decrease during the charging or discharge. So PCM, thermal energy storage applications, cooling and heating of buildings, use of peak rates and reduction of installed power, because this is for energy management also people are using this storage, because the electricity tariff is different at this ice making for air conditioning application has two advantages. One is to harvest the solar energy for our air conditioning application, and otherwise electricity tariff is also different. Some of the countries, the night time, they do not know what to do with the energy generation, so they sell the electricity at the cheaper rate. So at the cheaper rate, when it is available, you can run your air conditioning chiller plant and generate large quantity of ice, and that ice cool energy you can use it during our peak tariff hours. So electricity tariff is different. Even some many countries, 20% of the electricity, there will be a difference between peak tariff hours and off-peak hours. 25% value only will be there during off-peak hours compared to the peak hours. So in those situations also, you can make use of this thermal energy storage, latent heat thermal energy, PCM-based storage. In thermal protection of electronic devices also, it has a lot of application. And transport, nowadays in the vehicle, you are taking some food items in the vehicles. In the vehicles now they keep ice on the side so that this food will not get spoiled. And medical, some medicine also, when it is being transported, this kind of arrangement is there. And you can see here that during this phase change, the latent heat part is very high. So large quantity of energy can be stored at a constant temperature. So isothermal behavior you can see in the latent heat storage. during charging and discharge. And these are the various phase change materials. These are the various phase change materials, organic, inorganic, eutectics, the organic paraffin wax itself, paraffin wax with some additives, you can change the phase change temperature of the paraffin. There is one company in Germany, it is called, one company in Germany, they are making paraffin which will freeze at different temperature. It will freeze at different temperature. In our refinery, we get paraffin which will which will melt at some 40 degrees centigrade to 760 degrees centigrade. But with some additives, this company, this company can change its phase change temperature at a constant level, also at a different temperature. So you will get paraffin which will change its phase at 60 degrees centigrade, RT. Yeah, this company is called Rubitha. RT 60 means that paraffin will change its phase at 60 degrees centigrade. They have RT 70, RT 80, RT 90, like that. They have different temperature. This paraffin will change its phase. Like that, different fatty acids also available, which can be used as a phase changing material. So for your various application, what temperature you need, accordingly you select the phase change material that should melt and freeze at that particular temperature. Salt hydrates and eutectic materials are also available as phase change materials. So these are the selection criteria. When you select the correct phase change storage materials, there are some criteria you need to check: the thermodynamic properties, kinetic properties, chemical properties, and of course economic property. It should be available at low cost. There are many materials which will have all these properties, chemical, thermomechanical properties, but economically it is not viable, means you cannot use it in a large scale. So in my specialization is, in the last 25 years I have done only on the thermal storage, energy storage technologies. So initially I started my research in the area of heat transfer for melting and solidification. Initially when I did my research, I didn't know about these applications. So simply with the heat transfer, melting and solidification heat transfer only I started. So throughout till I completed my research, I didn't know about the vast application possible with my heat transfer knowledge. So in the heat transfer, melting and solidification, and the numerical studies and theoretical studies, and also some experimental how it works. Because the dynamics is not so easy. So when it changes its phase, the interface, once the solidification started, the resistance will enhance. So it is not so easy to make the uniform heat transfer during the discharge. So how to enhance the heat transfer enhancement, and numerical studies, melting and solidification, the heat transfer rate studies, all these I have done it during my research, PhD research. I got the opportunity to work in Germany during this heat transfer studies. So I understood the dynamics of melting and solidification very much, but after that only I found there are so much application possible with this melting and solidification in solar, electronic cooling, and various applications. So some of the research. So after that I have supervised many research teams. So most of the teams will have one application, any one application. With the thermal storage, the heat transfer studies, though the heat transfer studies, along with some applications only I have done. So interestingly, you can see some of the research work which are done using thermal energy storage. So these are the various applications. So at least one scholar has completed this solar water heating system. Dr. Nallaswamy from presently he is registrar Shivanadar University. He has done on this application, solar water heating application, solar cooking system Dr. Kumaresan, Dr. G. Kumaresan, presently he is the director research of our Anna University. He has done on solar cooking system, energy storage, all thermal energy storage. And solar air heating system, one scholar who is working in a polytechnic, he worked in the solar air heating system. He has done it in one industry in Kodaikanal near Theni. One industry he has done with the storage system. Solar cooling system with the vapor absorption refrigeration system also one student from Annamalai University, he has done it. And passive building cooling system, Dr. Anthony and a few other scholars also have done it. And building thermal management system, that is also, this is active and passive way of doing. And this one interesting work I will show as a case study, which is building thermal management system. We haven't done research work because it is already established one, successful commercially viable technology, which is also available in Tidal Park, Chennai. Now in many of the high-rise buildings, this kind of storage system, cool thermal storage system is available. And of course, thermal management of electronics also few scholars have done it. Waste heat recovery system, even our coordinator, Dr. CHINNAPANDIAN and Dr. Pandirajan, they have done it on waste heat recovery system. So these are the various applications different research scholars have completed, how this thermal energy storage we can couple with the charging and discharging behavior. Mostly it is useful for solar applications, except this waste heat recovery for IC engine integration. So solar water heating, existing system possesses disadvantages of normally, if for very high hotels and all, if solar thermal collectors are integrated, you need large storage tanks, large capacity storage tank. So there if you use some paraffin kind of material, how we can reduce this capacity of the storage tanks, but the heat energy stored will be very high. So for which we have done some work. TES, thermal energy storage, is integrated with the hot water storage tanks combined. So this is a small example. So you can see there is a balls in which this paraffin is built so that in this small storage tank you can store large quantity of heat. So suppose from this storage tank, if it is sensible heat storage, only water is stored, only 2%, only 1% can take bath, means from this storage system, some 3% can, the hot water available in the storage will keep on coming because the heat energy in the paraffin will keep on giving release its energy. So for very good hotels and all, this kind of storage tank will be very helpful to reduce the size of the storage tank. So solar water heating, the major advantages you can see, and solar cooking project also we have done, because solar cooking, though it is not well commercialized, if it is used, I have my supervisor in Germany, he has one very good solar cooking system in his house, and whenever there is a party, he uses the solar cooking system to prepare all the food items. And the solar cooking system is very well being utilized in very big hostels like buildings, and some of the Tirupati Devasthanam also, they have some storage system. They have storage system. From this they can solar based cooking system with the energy storage. So even in some of the hostels and big university hostels also, it is solar cooking is available. So there, if it is storage is also available, how it is can be used. So we have done some storage system here with the PCM based storage. So how long you can extend this? The nighttime solar cooking, the major disadvantage is you can cook only for your daytime requirement, early morning requirement, and nighttime requirement, it is not possible. So if you are able to store energy in your phase change material, how it is possible? So we have done experiments with to store energy at a temperature of 160 degrees centigrade. We have used some material, phase change material that will change its phase at 160 degrees centigrade, so that how it is possible to use cooking at the night time. That also we have made an attempt. For air heating application, this we have done it for one company in Teni. So this is solar air heating application. So the major advantage what they got, if the phase change material is integrated with the solar dryer, here you have thermal storage tank. Thermal storage tank is there. So the hot air coming from the solar collector, before it passes through the drying section, energy stored means first the major advantage what you get is uniform temperature we can maintain. Uniform temperature. Otherwise, if there is a cloud, the temperature will suddenly reduce in the solar air heating applications. So we have done experiment with the PCM. So uniform heating we have achieved, and also we have extended the duration of drying for at least 3 to 4 hours after the sunshine hours. So some of the materials we need to dry 2 or 3 days. So there in the night, if we stop, what happens? Again, it will absorb moisture. Then again, we have to start. So this, if it is with the storage, we can continuously dry the material. So it has certain applications, certain advantages. And this is one experiment we have done it with vapor absorption refrigeration application, solar. But this technology now, sometimes it is useful in the sense if waste heat is abundantly available in some industries, they are using vapor absorption refrigeration system. Vapor absorption. But if you use solar, as I told you already, solar photovoltaic is cheaper than solar thermal based vapor absorption system, because now vapor absorption system is not good for solar based, but waste heat is available plenty means there are some industries they go for vapor absorption based refrigeration system. Hope mechanical engineers can understand what is vapor absorption refrigeration system, where you can generate cool energy from heat energy. Vapor absorption system is cool energy you can generate from electricity means it is vapor compression refrigeration system. If cool energy is generated from heat energy, it is vapor absorption refrigeration system. But solar based vapor absorption system is not recommended because now solar electricity became cheaper. Solar electricity became cheaper. But still, this technology is being used wherever waste heat is abundantly available in industry. So we have done some good work on vapor absorption system, how we can store and continuously operate for certain applications. Cool energy at what temperature you can store. We have done some experiment. And the passive architecture. So solar energy. So with the passive architecture means some of the buildings like very thick wall buildings. You can see in some of the buildings in Karaikudi, Chettinad houses, if you see, the building walls are so thick. The sun energy will be absorbed by the walls till the sun sets, so that the temperature of the internal temperature of the room will not enhance. Suppose the solar energy, when it falls on this big wall, thermal mass will be very high on the wall. Okay. So this energy can be stored. This energy can be stored in the wall material so that the wall will not increase its temperature from 30 degree to 31, 32. It will not go. Less than 30 degree will be maintained inside the room also, so that it is comfortable. So our old houses, our temple architecture, if you see, it is all very nicely built. But of late, what happened? The civil engineers have done very good research with the strength of material. The civil engineers, I should not blame some of the engineers, participants may be civil engineers, but unfortunately, in our technical education system, the civil engineers, they are not studying any thermal subjects. thermodynamics or heat transfer, they don't study. So they deal with only strength of material. So what with their good research in the last 50 to 60 years, they have found out they have invented a lot of very good material which will have very good strength. Because of that very good strength, all the thick wall buildings, they have made it a very thin wall. In the recent years, all the buildings are constructed with a thin wall. So because of the thin wall, what happened? The sun energy, because they don't deal with the human comfort, space comfort about that, they don't deal. Only air conditioning engineers knows about that. The civil engineers, they don't bother about what is the comfort required for the human being inside the room. So they constructed with the high strength material so that the investment cost of the buildings, they have reduced. But what happened? When the sun rises, immediately at 11 o'clock, all the energy will start entering into the building and the building inside temperature starts increasing. So the high intense civil engineers research gave opportunity to the mechanical air conditioning engineers. So the number of air conditioning requirement increases in the last few years because of the civil engineers' contribution for the last 50 years of high intense research. So then the air conditioning increases in air conditioning investment is very low. Correct. But air conditioning maintenance cost, the electricity cost is very, very high. You know, the air conditioning, one building in Tidal Park, which is located in the old Mahabalipuram road from Adayar. So one building, they are paying nearly 40 crores as electricity bill. One building is paying 40 crores as electricity bill for 1 year. It is very high amount because of air conditioning. Air conditioning is very energy intensive, very expensive. Operational cost is very, very high. So the civil engineers gave opportunity to the mechanical engineers. You should know at this point, I want to tell one more point. Any research, the researchers, even a Nobel laureate also, their knowledge level is within a small boundary. Whatever they invent within the system may be good within the system, but out of the boundary they are making lot of disaster. Okay, so anybody's knowledge in any research is limited within the system. When they make perfection in the system, they make large disorder in the surrounding. Like that, civil engineers research made lot of disorder, which gave opportunity for the mechanical engineers, air conditioning engineers. But air conditioning engineers with a lot of air conditioning systems, the operational cost is very, very high. Then all the building owners, now they are looking for passive buildings. How you can make it energy inexpensive, that is with the low cost, low maintenance cost, how it is possible. So now all the buildings became very thin wall. So now if you are adding some panel with the PCM material on the wall, panel PCM board on the wall, the energy which is coming from that phase change material should be, you should select with some phase change temperature of some 27 to 30 degrees centigrade. So that material with the panel comprising this inside filled with this phase change material, if you make it as a panel on the wall, then this material will melt and that will not allow heat to enter inside the room. So that kind of passive architecture also now people are making an attempt. So we have also made an attempt. So you can see there is another concept. This is PCM integration in the wall so that solar energy which is coming in the daytime can be absorbed by this so that the temperature will not increase. But at the same time, this energy stored also will be useful in the night time for some small amount of heating. Because many areas like desert area, our Chennai is coastal area. So can I take another 5 minutes, Dr. CHINNAPANDIAN?
Yes, sir. Yes, sir. Yes, sir.
Yes. So our area is coastal area. The coastal area, the temperature, diurnal temperature variation is very, very low. Daytime and nighttime temperature is very low. So here the temperature variation will be between some 28 to 35 degrees centigrade only. The ambient temperature variation will be there. But in the desert area or the area which is far away from the coastal zone like Delhi and Rajasthan, the diurnal temperature variation is very, very high. There will be a temperature variation between night time and daytime will be around some 13 to 15 degrees centigrade. In this area, if you have this kind of panel, the energy which is stored in this daytime can be utilized for nighttime heating also. So it is double purpose. So nighttime, daytime it is preventing the solar energy entry into the building, but the energy stored also can be utilized for nighttime heating. So this is very good passive construction is possible. And also we have done some experiment. So some areas like Bangalore city, so we have done some experiment with one with PCM on the rooftop, another without PCM, and how this variation is there inside the room that we have checked. And this is the material we have used to check this variation. This is the panel we have laid on the top of the room, small room we have made. This is the property of the material which we have used. Okay, so we are able to achieve near uniform temperature inside the room using this material. So these are the temperature variation inside the room at various hours. And another concept also I want to tell, free cooling concept. This is the cities like Bangalore city, that sometimes the air condition will be on. The air conditioning is to cool the room, to reduce the temperature which is generated internally. The outside temperature will be really lower than the internal temperature. So most of the time, the outside temperature is comfort only. The night time, the temperature is very, very low in Bangalore city. So if you have some PCM kind of storage, large storage, the night time free air can be circulated through this storage tank and freeze the pasting material. Then daytime you can circulate the atmospheric air through the storage tank and then supply this cool air to this room so that you don't require any vapor compression cooling system at all. So this is free cooling system or night cooling system. This is also being well researched in the many countries. Shortly, it may come as a good technology. Commercial, if once it is commercially viable, definitely this will take care. We have done experimental work. We have simulated because in the lab itself we have simulated this one room and we have generated cool energy, and this is the storage tank where cool energy is stored. How much cool energy you can store for space cooling application. We have done some experiment, and this is another application in tidal. This is a case study in tidal park where you can store cool energy in ice. So that already I told you, this has two applications. One is for demand side management, for electricity tariff utilization effectively, and another is for solar energy utilization efficiently. In the coming years, this technology will get higher advantages because everybody is trying to utilize solar energy aggressively. That means all countries are trying to enhance their solar energy share in the total power generation. So for which this thermal storage for air conditioning application also will be very, very helpful. So this is a case study which we have done at Tidal Park. On consultancy work we have done it for Tidal Park after their installation. So we have learned from the case study which we have done. So this is the number of occupants working in the Tidal Park is 10,000. Carpet area is 93,000 meters squared. So their annual consumption is 3.6 into 10 power 7 units. So their air conditioning requirement is only 53% of the total energy requirement. 40 crores they are paying means nearly some 23 crores they are spending for air conditioning requirement only. So this is their load variation during when they constructed the building. They expected the load variation will be from morning 9 o'clock 3,000 tons to 6,000 tons, and it will reduce like this. But later what happened, Many of the industries located, software companies located in Tidal Park, they work during the night time also because the Indians, they work for US companies and other European companies. So even during the night time, they need air conditioning. So their actual load behave like this. So they have installed, because of this, they have installed, you see, their requirement is 6,000 TR, but they actually installed only 3,000 TR with a full storage capacity of 24,000 ton hour. You should know kilowatt means power, kilowatt hour means energy. Like that, ton means the capacity of the air conditioning system, ton hour means the energy utilized by this air conditioning system. So here 24,000 ton hour is stored means if you want to use 1,000 tons, that storage tank will deliver 24 hours. 24,000 ton hour is available. If you use this cooling capacity at the rate of 1,000 tons, this storage tank can deliver for 24 hours. They have the capacity of 24,000 ton hour. So this is the storage tank available in this tidal park. They have some 4 storage tanks. So each has the capacity of 6,000 tons, ton hour. So 24,000 ton hour they have. And these are the 4 tanks. Because of this, they are able to reduce. This is the plate heat exchanger, which will decide how much energy to be sent to the air handling unit. So the cool water from the storage tank will come to this plate heat exchanger that will transfer the air to the chilled water. The chilled water will be taken to the air handling unit. So based on the load, this will decide the load, the plate heat exchanger. So this has advantage, as I told you, 2 advantage to promote the solar energy in a big way, and also for demand side management. This is very, very useful. So this has lot of advantage. So due to shortage of time, I want to stop with this. So there are a lot of research potential possible with the thermal storage. You can still, there are a lot of commercial viability you can make for different applications. It's a very interesting topic. Once you start involving in this research, every day you may think there are so many applications possible. Patenting is very easily possible. Commercial viability is also there if you take risk. And definitely it is very interesting topic for any researchers. And I thank the organizers for the opportunity, and I hope that all the participants have got some insights of what is thermal storage and how it is very useful for solar thermal energy promotion. Solar energy promotion, not only solar thermal energy, for solar energy promotion also, this is very, thermal energy storage is very, very useful. And for solar thermal application also, it is directly used. So with this, I stop here. And I thank the organizers once again for the opportunity, and I thank all the participants for the patient listening. And if you have any queries, I am available for 2 or 3 questions. Thank you.
All participants
So thank you very much for your valuable presentation, sir, to our participants. It's really very thankful to you, sir. You are spent towards nearly 1.5 hours to took this session with the inauguration function, and also he has really our participants gained a lot of knowledge from you. You are the only persons can give this much depth of knowledge to our participants. Really thankful, sir, and participants also very much on behalf of participants and management. Thank you very much. Thankful to you, sir. Thank you, sir.
Okay, thank you. Thank you.
Thank you, sir.